Hi everyone, welcome to CS 188 section 9, and today we'll be going over the solutions to HMMs and particle filters. So first we're going to consider the following HMM, which has hidden states, we're actually going to call them X instead of W, and observations O1 and O2. We have the initial distribution over X1, we have the transition probability, and we also have the observation probability. Now they say suppose that we observe O1 equals A and O2 equals B. They want us to use the forward algorithm to calculate the probability distribution, probability of x2, given O1 equals A and O2 equals B. So we're going to do this step by step. First, we're going to compute the probability of x1 given O1 equals A. So this is the observation step. So we can write this as probability of x1, comma O1 equals A. Just looking at the Bayes-Net structure of the HMM, we can rewrite this as probability of x1 times probability of O1 equals A given x1. So now we calculate for both values of x1. So probability that x1 equals 0, comma O1 equals A. So probability x1 is 0 is equal to 0.3. And probability O1 equals A given x1 equals 0 is 0.9, so that equals 0.27. And now the probability x1 equals 1, comma O1 equals A equals, well, the probability of x1 equals 1 is 0.7, and probability O1 equals A given x1 equals 1 is 0.5. That equals 0.35. So now number 2. Using the previous calculation, compute probability of x2 given O1, x2 comma O1 equals A. So this is going to be passage of time, so we can rewrite this. Probability of x2 comma O1 equals A as the sum over all x1. The probability of x1 comma O1 equals A, and the transition probability, so probability of x2 given x1. So now we do this for both values of x2. So for probability of x2 equals 0, comma O1 equals A. So first we'll consider when x1 equals 0. So when x1 equals 0, from the previous part, the first term will be 0.27. And the probability we come from 0 and we go to 0 is going to be 0.4. Plus, probability, now let's do x1 equals 1. So from the previous part, this will be 0.35. And the probability we go from 1 to 0 is 0.8. And this equals 0.388. Now we do this for x2 equals 1. So again, we're going to actually have the same exact values for these first terms. So that'll be 0.27 and this will be 0.35. But now our transition probabilities will be different. So what's probability we go from 0 to 1? Well, it's 0.6. And the probability we go from 1 to 1 is 0.2. So this equals 0.232. Okay, now using the previous calculation, compute probability of x2, comma O1 equals A, comma O2 equals B. So this is an observation update. So we can write this as probability of x2, comma O1 equals A, comma O2 equals B, as probability of x2 and O1 equals A times the probability of the observation O2 equals B given x2. So now we do this for both values of x2. So we have probability of x2 equals 0, O1 equals A, comma O2 equals B. So for the first term, this is from our previous calculation, so this will be 0.388. And now the probability of O2 equals B given x2 equals 0 is 0.1. 1. So this gives us 0.0388. And now we do this for x2 equals 1, O1 equals A, comma, O2 equals B. So the first term is from the previous part, so 0.232. And the probability of O2 equals B given x2 equals 1 is 0.5. So this equals 0.116. Now given 3, we could actually compute the probability of x2 given O1 equals A and O2 equals B by using Bayes' rule. Okay, so now we're going to move on to particle filtering. So they say, let's try to use particle filtering to estimate the distribution of probability of x2 given O1 equals A and O2 equals B. We start with two particles, so P1 equals 0 and P2 equals 1, and we're going to use the following random numbers. So first, they want us to compute the weight of the two particles after evidence O1 equals A. So the weight of particle 1 equals the probability that the observation at O1 equals A given xt equals 0, because the first particle is 0. And if we look in our table, find that this is 0.9. And the weight of particle 2 is the probability that O1 equals A given, well, particle 2 is, it should be 1, is actually, so particle 2 has value 1. So we can look this up in our table and find the weight to be 0.5. So now we do the resampling step of particle filtering. So using the random numbers, resample P1 and P2 based on the weights. So after normalizing, we have a distribution, so we choose to resample P1 if the number drawn is less than 0.9 divided by 0.9 plus 0.5, and that equals 0.643. If it's greater than, we'll sample particle P2. So our new particle P1 will equal let's sample the weights, and our number is 0.22, and we see that this is less than 0.643, so the value we're going to assign it is whatever P1 is, and P1 was 0, so it'll still be 0. Now P2 is we sample again from weights, and we use a different random number, the next one, so we already used that. Now we're going to use 0.05. This is also less than 0.643, so we're going to sample what particle P1 was, and P1 was 0. Okay, so now both particles are now 0. So now in part 3, now let's compute the elapsed time particle update. Sample P1 and P2 from applying the time update. So P1 equals, we sample from the transition distribution, probability of xt plus 1 given xt equals 0, because that's where particle 1 is. And our random number is 0.33. So now we look at the table. So given xt equals 0, we will, 0.33 is less than 0.4, so we're going to stay in 0. Now we do the same thing for P2 equals sample, so use data, sample probability of xt plus 1 given xt equals 0, because that's what particle 2 is, and our random number is 0.20. So based on the table, since it's less than 0.4, this will actually remain at 0. Now we compute the weight of the two particles after evidence O2 equals B. So the weight of particle 1 equals the probability that OT, that the observation is B, given that, well, particle 1 is value 0. And if we look in our table, we find that this is 0.1. And the weight of particle 2 is actually going to be the same exact thing. So OT equals B given XT equals 0. So that will also be 0.1. So now in step 5, they say using the random numbers, resample P1 and P2 based on the weights. Well, actually, well, we noticed that P1 and P2 are both 0. So right now, P1 equals P2 equals 0. So since we're resampling from these particles and all the particles are 0, it's going to stay the same. So after resampling, no matter what, there'll be P1 equals 0 and P2 equals 0. Okay, so now for number 6. What is our estimated distribution for the probability of x2 given O1 equals A and O2 equals B? So we can say that the probability of x2 equals 0 given O1 equals A and O2 equals B. So we just count out the particles. So particle 1 and 2 are both 0, so there's 2 of them, and there's a total of 2 particles equals 1. So the probability that x2 equals 1 given O1 equals A and O2 equals B, well, on top there's no particles that are 1, have value 1, so there's none of them, and there's a total of 2 particles, so that equals 0.